So, yeah, welcome back once again. And today we'll have introduction to software testing. Okay, so let's go through the table of contents and what we'll be covering today. So for our table of contents, we'll look into the background of testing. Okay, what is software testing? Why testing is important? General principle of testing, fundamentals of testing, different rules in software testing, skills of a software tester. All right. So this is just to, know around testing and what is involved. Okay. So we'll just go straight into it. Right. We'll just go straight into background of testing. Okay. So without wasting time, as we can see, that testing is a crucial process that involves the evaluation and validation of software products to ensure it meets specific requirements or the specified requirements and functions as expected, right? So what does this generally mean, right? So it means that once we have a software, right, or a functionality or a component in a software, and we are told that this software should function in a particular way, okay? Once we've gone into it and it's been given to us, the developer has done, their bit, they've built it, they've done their, unit testing, and they've given it to us as a tester, right? We will go into it and then check to ensure that it has met its specified requirements, right? Let's say we're testing for a login functionality, basically, and you are told that once we enter a valid username and valid password, that it should log us in, right? So you go there, you enter valid username, you enter valid password, and click on login button, and you are expected to log in, right? So if that happens, that means it's functioning as expected. But if it throws an error, that means it's not functioning as expected. So that means there's a bug or a defect there, right? So that's what software testing or testing in general basically means, right? So testing is not limited to software. Of course, we'll test other things. We'll test hardwares, we'll test so many other things. Anything basically, right? You can actually test it. Okay, so we will take a few scenarios which aren't related to software testing, and we'll try and make it to be more interactive instead of me just going and blabbing. And let's make it interactive, right? So let's start with something that is not a software. Okay, let's say a cake. Okay, and then let me get your thought process as well. Okay, so I'm giving you a scenario, which is scenario one, right? And it just goes by you imagining you are baking a cake, right? Then you are done baking the cake, right? And you want to serve it to your guests. What do you do? Do you just bake the cake and then serve it to guests, or serve it to your guests? Let's make it interactive, Oluwale. Do you just bake the cake and serve it to your guests? What do you do?
You dissect them.
You dissect it.
Yes, like when you are dissecting, all these rats for practical.
Really? You just dissect it? Is it because the cake that we have on the slide is dissected? Do you just dissect it? Va, what would you do? Hello? What would you do, Val? Okay, so of course we know, right? When we bake a cake, yeah, like let's say you dissect it. But when you dissect it, what do? You don't just dissect it, you test it, isn't it? Right? We'll test it. We want to test, you want to see that it's properly cooked, right? You want to see that it's properly baked. You don't want to serve a half-baked, cake to your guest, right? You want to test it. You want to ensure that the sugar, all the ingredients are the appropriate, proportion. You want to check that it tastes well. Okay. You want to check that it's cooked well. You want to check that it's delicious, right? So that is you testing. You are testing the cake. So you've baked this cake before you serve it to your guests. You want to test it. So that is what we also do in software testing, right? Once the development team are done building a particular functionality, the next thing they do is to test it, right? We test it to ensure that it has met the expected condition, right? So let's take another scenario, okay? So before we take another scenario, let's see what we have on the slide, right? So before serving to your guests, you make sure it tastes delicious and look perfect, right? You check the texture and you check the texture to see if it's cooked thoroughly or if it cooked through. Okay, you want to make sure that it's properly cooked. So that is what you do. And there are so many other things you want to do. You want to make sure, look at the physical appearance. You want to make sure that all the icing are correct, that the design, is perfect. Everything basically. Let's say the owner of the cake, the people that are coming to eat the cake say, okay, that they would like you to, they like a particular color. They want you to design the cake with a particular kind of icing, right? So you want to make sure that you've use that particular kind of icing with that particular kind of color to actually bake and design the cake. Okay, so yeah, that is how it is with testing. So let's look at another scenario. So we have scenario two. Imagine you are buying a car from a showroom. So before you take that car home, what are your expectations of the car? What do you expect? You've gone to a showroom, right? And you want to buy this car. What are your expectations of the car? Any suggestion? Olawale, Valentine, what would be your expectation?
Before you take the car home, what are your expectations of the car?
Yeah.
Yeah, if I'm buying a car before I take it home, I will expect the car to perform exactly as what I've dreamed of. If
Yeah.
I'm buying a Lamborghini,
Mm-hmm.
I will expect the car to run as far as I expected. So I
Yeah.
will do a test driving.
Perfect.
Yes, I will do a
Absolutely.
test driving
Mm-hmm.
on the A19 or A45 way. So I will speed and I'll make sure. And I also ask for a warrant so that
Mm-hmm.
I'll take it home and test it for a year or three. So if I'm satisfied, then I can continue using it. If not, then I'll return it back to the dealer.
Mm-hmm. Yeah, okay, yeah, that makes sense. You will have to test it, right? To see
Yeah.
that once you are moving or once you are driving it, that you don't hear any engine, sound that is abnormal, right? Or it's not moving as expected. Because when you are buying a Lamborghini, for example, like you said, you are expecting that it speeds up, right? Whenever you match on the gas, right? You want to ensure that it's speeding as expected, right? So yeah, apart from the speed, right, there are other things you also need to look at. You need to look at the body as well. You need to ensure that it's not scratched, right? Because some of the car, that is being displayed, yeah, of course, your expectation going in is that, the body will be clean, the paint will be clean. You are not expecting to see any scratch on it. So when you go there, you have to look around it, look around the body to make sure that, of course, it doesn't have any dent on it, right? You also want to make sure that, all the pre-sale check are completed and passed at factory. You want to make sure that when you're on the ignition, if it's a button or you're using the key to, on it, you want to make sure that it's, when you turn on the ignition, that the engine will, turn on. Okay. You want to make sure that, let's say you are going in with an expectation, you want to buy a blue car, you want to make sure that the car that you're taking home is blue color, right? Because that is your expectation, right? And then, like Vincent said, you go for a test drive, right? You want to go to a test drive, you want to make sure that you are certified, right? You are satisfied with the speed, the performance, and everything. You want to check the side mirror, you want to check the inner, the windscreen, and the rear screen. You want to make sure that all the lights, everything basically. So those things that you are going in with an expectation, right? And if your expectations are met, that means after testing, after checking all those things, all these things that I've mentioned, if your expectations are met, that means that the car has passed your test and you're happy to take it home, right? So that is how it is. So let's look at what I have. So yeah, like I said, so it does not have, you want to, before you take the car home, right? What are your expectations? You want to expect that it does not have any scratches, that all the preset check are completed and passed satisfactory. You should be in a correct color, and what extra you ordered, right? If you've ordered that, yeah, it should have, an extra tire or whatever thing, that the seat should be covered in, with a particular design, basically. So you want to make sure that all those things are there. You go on a test drive, right, to ensure that, to make sure that that you are satisfied with the car, basically. So these are the things you are going to do. And by so doing, you are testing. You are actually testing that car. or you've performed testing on that car. So those are the similar thing we'll do as a software tester, right? Once you are given the software, you are given the requirements, you go on it. If they say the background color should be gray or should be blue, you want to make sure that the background color is blue. If they say that the button, when you hover on it, you should change the color to, it should be responsive and the color should change to yellow. You want to make sure that when you go there, you perform, right? That hovering on that particular button, you want to make sure that it turns to yellow, right? If they say when you enter a particular, data, right, on a particular field, input field, that it should only take numbers, basically, you want to make sure that when you enter number, it takes it, and when you enter an alphabet, right, or an alphanumeric value in it, that it doesn't take it. You want to make sure that when you enter a special character, that it doesn't take it, right? So this is your testing. If they say that this particular functionality should appear on the top left-hand corner, or these are the menu that they want to be in the header, you want to make sure that all those menus are on the header, okay, and at the right position. So that is you testing. Okay, so similar to all this, you are testing. Okay, so all these things you are doing are testing. You are actually testing. Okay, so in any project or software, testing helps to make sure that everything works correctly and meets expectation. Okay, so for example, if you are in an e-commerce website and you want to buy any products, okay, you want to buy any products, when you navigate to that website, firstly, obviously, you want to navigate to the website and you want to search for a product. Okay, so when you search for that product, you want to be able to view that product that you've searched for, right? And once you click on the right product, you want to make sure that you can see, where the functionality where you are, you'll be added to the cart, and when you add that to the cart, you want to make sure that you're able to pay. Okay, and once you're able to pay, you want to make sure that you've received, a message, that popped up that say yes, you've successfully ordered this, and so on and so forth. You want to successfully order it, right? So once you are given this website and you've gone through all these things and you've successfully ordered it, that means the website is performing as expected. Okay, so that is just what software testing is all about. So, like I said, similarly, in any project or software testing, make sure that everything works correctly and meets expectation. So that's what I've just explained. Okay, and then, like I've just been saying, I've been talking about testing and then relating it to software testing. Okay, so that it will make sense. It doesn't seem as though we are seeing something that is outside software testing. So now let's not focus on software testing. Okay, so what is software testing? Right, so software testing is no different from what we've been saying. Okay, the only thing now is that we are now focusing on software. Okay, which of course is software testing is a systematic process of evaluating a software application or system to identify and rectify any defects. Okay, is a process of evaluating. Okay, you evaluate a software application or system to identify and rectify any defects, errors, or discrepancy between expected and actual outcome. So expected outcome is the requirement that is being given to you. Okay, the actual outcome is what you are seeing when you've gone on that website. Okay, so for example, let's say you are testing a web application, right? And from the requirement, they say once you click on the registration, okay, it'll navigate you to the registration page. And the registration page should have enter your name, your first name, your username, and the registration page should have all the input field as required, right? And then you've gone to the web. That is the expected. So you are not expecting that once you get into that web application and you've clicked on the registration on the header menu, okay, and once you click on that, you will see the registration page and all the fields are required. And when that is the expectation, you have that in mind. You've already used that requirement to write your test cases. And once you've gone on it and click on the registration, and you find out that all the fields are not required. You don't have any mandatory field on there, and you can go ahead and submit an empty field registration form. Okay, so that is what you are seeing there is now your actual, because you've gone there and you are seeing the actual, right? So you can say that the expectation hasn't met the actual. There are discrepancy between the expected and the actual, and there's a bug on it. So you can raise that as a bug. Okay, so that is what software testing is all about. And then we can go ahead to what can be tested. What can be tested, like I've mentioned before, we can test various hardwares. Some organization, you know, will ask you to test a particular hardware, or even some most often in an interview, they will ask you, how can you test a vending machine? It's not like when you get into the organization, you'll be testing their vending machine, but they want to find your thought process, if you actually understand the fundamental of software test. Because it's not all about writing code, you can know all the C# code or any kind of, programming language, you can know how to use it to write an automated test scripts. Okay. But sometimes recruiters want to actually make sure that you understand the fundamentals of software testing. They want to make sure that you get what software testing is all about. Okay. So we test various hardware, and I've seen also some organization that you can be hired as a software tester and they deal on hardwares, right? So they want you to test how they want you to test their, could be mobile phone, it could be card, it could be anything basically. It could be the laptop, it could be TVs, it could be different kind of device, So yeah. So you test hardwares and as well as software application. So as a software tester, sometimes you call upon, like in my place of work, I have to, test a particular web application and mobile application with the use of a device. Okay, one, I have to look at how the device interacts with our software, and so on and so forth. So, like I say, you test hardwares as well as software application can be tested to ensure their quality, reliability, and functionality are met. Okay, you want to ensure that the hardware and the software application, meets their expected condition. So that is to say that we can test hardwares and we can as well test softwares. Okay, so let's look at, like I said, this is going to be an overview of all the things we need to know. Okay, so now what else do we want to know? We want to know, how can software be tested? How can software be tested? It's very easy, very, very easy. So software can be tested manually, and we can automate that softwares. So how do we test it manually? Of course, you know how we navigate our Facebook and press, to check. So let's say you are testing Facebook, for example. You can navigate on Facebook. You want to make sure that you can log in. You want to make sure that you can read, that all the visible, all the stories or profile, everything that is posted on Facebook is working as expected. You want to make sure that you can upload pictures. You want to make sure you can stream videos. Depending on the requirements. So you manually do it. So let's say you're testing a website, for example, you want to test PrimeSoft website, you manually navigate to the website. Okay, you click on it. Let's say you want to register as a student, for example. So you can manually navigate to the PrimeSoft website. You can, click on register or training. You want to select the course that you want to, do, and then you also want to fill in your form, fill in your profile, your details, and then you also want to, select what payment method you want, and then click on enter. Okay, so once you have done that manually and you've successfully registered, so that is you testing that particular functionality. Or let's say you are a big data company and you want PrimeSoft, to build dashboard for you. Okay, maybe you want to visualize the sale or how you are performing, right? So and as a tester, you are asked to follow that customer journey. You've been given the requirements, all the acceptance criteria, and you want to go in and test it. Okay, so you as a tester will follow the same user journey, everything that user is meant to do. Okay, following the acceptance criteria and the requirements. You follow it, enter everything, and make sure that you're able to maybe book an appointment to speak with one of the consultants, and that the process is seamless, right? So once everything has passed, the actual has made the expected. That means you are good. The test has passed. But if you're not able to do that, that means the test has failed. So this is you manually going to the website and doing it. That is manual testing. So, but the automated part of it is you writing a code, okay, using the right automated test framework. Okay, you write the code, and then when you run it, this piece of code will do the same thing, the exact same thing that you're going to do manually. Okay, once you run it, you will navigate to the website, you will click on training. Let's say you're doing the student journey, you click on training, it will select the course, it would fill in the forms, fill in the details, click which payment method, and then fill in all the necessary thing and click on submit, and then we'll validate that you've successfully registered. That is the automated part of it. Okay, so we'll come into manual testing and automation testing in more detail, but we'll just briefly go through it. Okay, and after that, why do we test? That is what we have on our next slide. Why do we test? Why do we test? Okay, why do we test? We want to know why we test. Of course, it's very simple. As you can see, we test to make sure that the quality that will give quality assurance, basically, right? So the first one we have is quality assurance. Okay, we have bug detection and correction, we have customer confidence and satisfaction, and we have risk mitigation. So those are few of the reasons why we test. There are so many of them, so many reasons why we test. Okay, so we'll go through them one after the other. Like I said, quality assurance. Okay, so testing is a fundamental component of quality assurance, aiming to deliver a software product that meets specified requirements, function as intended, and is of high quality. Okay, so if we don't test, we cannot say, yeah, the quality of this software is high, and we cannot say that it has met its required or intended requirements, or the way we cannot say that it's performing as expected if you don't test it, right? You don't have that assurance. Okay, so most organizations, once a particular developers are done, they've run their unit testing and you haven't tested it, sometimes you can see them saying, I have no confidence on this, I have no confidence. But if they've got a software tester, they will, oh, have you tested it? And you say, and what do you think? Are you confident? You say, yes, I'm confident. They say, okay, good. Are you signing it off? You say, yes, I'm signing it off. I've tested it. You have your results. Everything is working as expected. Yeah, you are giving them that assurance that the quality is good. So those are one of the reasons why we test. And the next one is bug detection and correction. So if we don't test, we cannot identify bugs. If you don't test, you cannot say, okay, I think this button is missing. You cannot say there's an overlap between two cards. You cannot say that the button have different sizes. You cannot say that this input, field are certain, special characters if you don't test it, right? Because developers are human, and sometimes the workload, there might be too much workload, some of the constraints such as tight deadline, because it's actually code basically, so sometimes they can get their logic wrong. Sometimes the developers does not meticulously read the requirements and the acceptance criteria as we do, right? Because once those is written, they're already thinking of, okay, the logic, what logic would I need, right? So they pay much attention on the logic, trying to get what they actually, envisage that particular, or how they want that particular functionality to work. But for us testers, we focus on the requirement, or meticulously and carefully read the requirement and design adequate test case. And when we are testing, we test, we check the edge cases, we want to make sure that we try to break it. We'll try to think outside the box. Okay, we'll think as though we are the users, and then we'll try to see a way that, okay, things that users can do, because most developers are much more technical, so they focus on the technical part, but we want to make sure that, oh, I'm putting myself as though I'm a user, okay, on this website, and I'm testing it, and I can say, oh no, I'm finding it difficult to navigate through from this side to this side, or sometimes before, when I want to click a button, it scrolls up or it disappears, and all those things. So those are not good. So we detect bug while testing. And once that bug is detected, you raise it, okay, following the right means, adding all the bug components, okay, step to reproduce, screenshots, and so on and so forth, right? So for the developer to pick it and then work on it. Once that is being worked on and fixed, you will text it to make sure that everything is passing. So that's why we test. And then the other one is customer confidence and satisfaction. Okay, so through testing, we build customer. So there's this project that I did, okay, and then the developers are done testing, and then the manager has come up to the testing team and was like, we are not confident. The customers are scared that, I mean, the owners of the website, the web application are scared that when they have loads of, when they deploy that and it has gone live, right, that the system might break. So we said, okay, we have tested it, everything has passed. We've written automated tests, okay, and we have it running on our pipeline. So one, if it fails, we'll be the first people to, pick that up and it will fix and it will go out as hot fix immediately, even before the customers knew that the system is not working. Okay, and they were like, "Oh wow, that is good. At least we are confident and they are satisfied." So that's what testing does to us. Okay, it gives the customers satisfaction. Okay, they trust whatever that is being given to them, and they believe that the entire development team knows what they are doing. Okay, so the next one we have is risk mitigation. Okay, testing help identify and mitigate risk associated with software, such as security vulnerabilities, performance bottleneck, and compatibility issues. So there are some websites, okay, or web application that is not compatible to some device or not compatible to some browsers. So you can try to check it on on Chrome and it's working. And when you take the URL and you've entered it on the Edge or Firefox, it's not working as expected, right? Or it becomes so slow, meaning that it's not compatible with that particular browser. But when it's been tested, we'll check it across all these different browsers, we'll check it across different devices, we'll ensure that it's compatible both on Android and iOS. You will know that it's compatible both on desktop and mobile devices, right? Or even tablets. So it's ensured that any risk associated with compatibility issues are being removed. Okay, so now we still have many others, right? Such as compliance with requirements. Okay, so testing verified that the software meets specific requirements outlined during the development process. It ensures that the software aligns with intended functionality and business goal. Okay, we also have cost savings. Okay, we also test to, whenever you are doing anything in retrospective, it costs more, it wastes time, and it even costs more. Let's say an application has been built, right, and has been deployed with a proper testing, okay, and customers have started using it, and then when customers, the external users are using it and they're complaining, okay, they are not quite happy, maybe, let's say a fintech, application, right? You use it to send and receive money. And it's been promised to the customer that once you send money, within 10, 15 minutes, you receive it. And some customer has sent money and, because it's not properly tested to make sure that once you send money, that the person that you're sending it to will receive it within 10 minutes, right? And they've not done proper testing and they've deployed it, right? And then when customers start using it, right, they're not receiving money even after 2 days. Right? What does it do? It will cost the business more money because they will lose customer. Customer will lose faith. Okay, customer will not trust them anymore, and then they will have to go back to build it again to find out, investigate what the issue is, try to fix it again, and then when they bring it back, that trust issue will still be there. They've lost customer. Customer has gone move over to their competitors and so on and so on. But when this is properly tested, right, and once they say this is what this application does, and the customers are using it and it's actually doing that same thing, okay, so there will be no wasting of time going to review what the issue is and build it in retrospective. Okay, so it's testing actually save money. Okay, so the other thing that testing also do is that testing provides feedback on the software development process. It allows for continuous improvement by identifying areas for enhancement and optimization in both development and testing processes. So testing is crucial for delivering a reliable, high quality product that meets user expectation, complies with requirements, and operates effectively in various conditions. Okay, so now we've gone through why we test. Okay, so the next thing we have to do is, I've mentioned error, defects. So take note of everything that I'm saying because we will be encountering it. We'll keep anything that I've mentioned now, you keep hearing it, you keep hearing it all through your testing career. You keep hearing everything that is being mentioned here all through your testing career. So now we are going to, go through the errors, the defects, and failures, what they are. They sound so similar. look as though they mean the same, but you will just pay attention so you get the different how they relate with each other, basically. So now we'll start with error. Okay. An error, also known as a mistake or a fault, is a human action that produces incorrect results. Okay, it's a human action that produces what? Incorrect results. It is a deviation from the intended behavior of the software. Okay, so error can occur during various stages of software development life cycle, including requirement gathering, design, coding, or even in the testing phase. For example, a developer might make a coding mistake leading to an error in the software. So error could occur anywhere. It could be during the requirement gathering, that maybe the PO or the stakeholders are busy saying something else and the business analyst wrote something else. It's an error. It could occur anywhere. Okay, so it's a human mistake. Okay, so now let's look at what a defect is. Okay, a defect, also referred to as a bug or an issue. A defect, also referred to as a bug or an issue, is a manifestation of an error in the software. Okay, so let's say during requirement gathering, right, the business analyst has written something else that is not, what the business wants, right? And the business analyst has actually documented these requirements, which, is not correct, right? And then the developer has actually gone on and built it, right? And the business later find out, oh, no, this is not what I want, but it's been built. So at first, it's an error. So, but when it's been manifest on the website or web application, it becomes a defect, which is also a bug. Okay? So when an error occurs, it may result in one or more defects in the code. Defects are identified during testing processes when the actual behavior of the software deviates from the expected behavior defined in the requirements. Defects can encompass coding errors, okay, logic mistake, or other issues that impact the correctness or functionality of the software. Right. So the next one we'll have is failure, right? So a failure occurs when a defect causes the software to behave in a way that is inconsistent with the specified requirement. In other words, a failure is the observable or incorrect behavior of the software during its execution. Failure are the outcome of defects, and they are identified when the software does not meet the user expectation or produce incorrect results. Failure can occur in various situations, including during testing or in a live production environment. Okay, so you can see one is building on one. Okay, so we have error, which is a human mistake or a fault. Okay, when this occurs, it leads to defect. When a defect occurs, it leads to what? A failure. So you can see error leads to defect and defect leads to failure. An error, which is a mistake, leads to defect, which can cause an observable what? Failure. Okay, so let's look at what we have next. So incorrect software can harm. Incorrect software can harm. So as you all know, let's say, for example, okay, we'll have a software, that the airplane that we all, enjoy when we're traveling from one destination to another, being, controlled by a software. Okay, so let's say this particular software has been built and was not tested properly. Okay, and people has gone in and the pilot has taken off and the pilot has, changed everything and then enter it in autopilot, and then most often they will just relax. So as I was saying, that the pilot has, so the pilot has, changed, everything to autopilot, right? Yeah, all the settings, and then the pilot start relaxed, sipping their cup of tea or coffee, and then suddenly software started malfunctioning, what happens? So that could lead to, that could, cause the aircraft to crash and people die, or could cause, yeah, of course, when that happens, it will cause, if the software that controls the autopilot starts malfunctioning, right, it will cause the aircraft to crash, and people there might die. Okay, so then again, let's say take another example. We have a software, that you can use for diagnosis, because all these softwares are all these equipment that we use at the hospital are being controlled by softwares. Okay, and they malfunction. What happens? It could cause people to die, right? So when software are not properly tested and they are incorrect, they could harm people. Okay, they could affect companies and organizations, right? Take, for example, an organization that's, let's say, organization that, billing company, basically, right? Let's take uh, the railway, for example. Okay, they have softwares that they use, when you are traveling from London to, let's say, to Manchester, right? You can go on the website, on their mobile app, their software, mobile application, web application, go online, you can, put your location and then your destination, and the price comes up. So imagine you going on there, and then when you go on there, and from London to Manchester, instead of £15, you are seeing £200. That could happen as a result of incorrect software. Okay, and then that will subsequently lead to incorrect billing. Okay, and that could lead to organization losing money, because let's say someone that wasn't paying attention, and the person just flashed the card, and then it took £200 from them, and all of a sudden the person finally find out that, yeah, certain amount of money, and it could lead to company having issues, basically. So yeah, then the next one is environment. Of course, we all know that incorrect, software can harm the environment. Okay, let's say we have a software, that control radiation or something, that is working, in an incorrect way, and then it could release harmful chemicals, okay, to the atmosphere, which will subsequently affect lives, or subsequently affect company, or even subsequently affect environments. Okay, they affect the plant, the living things, and all that. So that's why we test softwares. Okay, and when you're a tester, you meticulously ensure that whatever that is on the requirement, okay, is what you are expecting, and that is what the actual result is giving you. That is what the website, what is on that web application. Okay, so yeah, so let's go to, when do we stop testing? So when do we stop testing? Okay, so just before I go to when do we stop testing? Okay, still on the what incorrect software can do. Okay, so when software fail, it can subsequently lead to loss of money, loss of time, loss of business reputation, injuries, and even as well as death. I've mentioned that. Okay, so you, as a software tester, you have to meticulously test your application to make sure that it has met its expected condition. Okay, so now, when do we stop testing? Okay, so there are few things, okay, that we'll consider before we say, oh, okay, we can actually stop testing. You have to consider those things. Okay, you say, okay, when do you keep testing and testing and going on and on and on and on and on and on when testing? Okay, or do you actually stop at some point and say, yeah, I think at this stage I'm done testing? Okay, so the first thing you have to bear in mind, okay, why testing and when considering to stop testing, is exhaustive testing. Exhaustive testing of complex system is not possible. So there are some system that, if you say you want to test every possible input, you want to take all the input, you want to go through all the edge cases, you want to run through all the data, everything, you want to test it exhaustively, right? You will spend years testing. Let's say, for example, right, you are asked to test, okay, that a particular website only takes people, okay, age 18 to 60. Okay, do you start testing from 16, 17, 18, 19, 20? You test 20 years, 21, 22, 23, 24, 25, up until 60 years? No, no, you won't do that. So you apply a testing technique, right, based on certain principle to test it. So there are so many other complex systems that you can actually say that I will make sure I will test every possible input combination, every possible, set of, inputs to make sure that I've tested it exhaustively. It's not possible. So if every test had been run, okay, testing would have gone on for, and the product would not be released to the customer. Okay, does that make sense? So what I'm trying to say here is, for some complex system, right, if you want to test every possible input combination, you will not finish your testing, basically. So you will keep testing on and on and on and on. Okay, so exhaustive testing of a complex system is not possible. So you have to bear that in mind. Okay, that will help you to determine when to stop testing. Okay, the second one is testing and risk. Okay, you need to bear the risk, you need to check the risk. Okay, you need to know that in software development, okay, risk is inherent and uncertainty increase with system complexity. Okay, testing should be proportionate to the risk. So if the risk is high, you make sure you spend more time testing. Okay, you make sure you have more intensive testing. Okay, so what I'm trying to say is that with more intensive testing required for complex system, where the probability and the impact of failure are high. So when in a complex system, you look at it, you look at where the risk is high, okay, and then you ensure that you test more extensively around those areas. Okay, so some areas like the free test, you look at it, yeah, it has passed, everything is okay, you move on. Okay, for the login functionality, you want to make sure that you try the positive, correct username, correct password. You want to make sure you try incorrect username and correct password. You want to make sure you try correct password and incorrect username. You want to make sure you try incorrect password, incorrect username. You want to make sure you try special characters and all that. Okay, so the next one is testing and quality. Okay, is testing and quality. Quality in software is often tied to meeting user requirements. Okay, so you cannot say I'm generalizing the quality of a particular website. It ties within the requirement. That's why you test with the requirements. Okay, testing play a crucial role in identifying and reporting both functional and non-functional issues, contributing to enhance system quality by facilitating defect removal. Okay, so the next one we have is deciding when enough is enough. Deciding when enough is enough. Okay, so determining the appropriate amount of testing involves prioritization based on the system's most crucial aspects. So like I was saying, so deciding when enough is enough, determining the appropriate amount of testing involves prioritization based on system's most crucial aspects. Okay, focusing on essential function and addressing significant risk. Okay, prioritizing the most important tests first ensure that even with a reduced testing activity, the key aspect has been addressed, establishing complete criteria such as defining the extent of testing and acceptable defect level, provides objective standard for deciding when it is safe to conclude testing, preventing confusion from time and other pressure. While compromise may be necessary, the approach ensures clarity or required testing level and maintain the importance of testing already conducted, regardless of the time or resources constraint. Okay, so now we'll go into general testing principle. General testing principle, right? So the International Software Testing Qualification Board, ISTQB, outlines 7 general testing principles that guide software testing practices. Okay, these principles are fundamental concepts that contribute to effective and efficient testing processes. Here are the 7 general principles. So we have 1. Okay, testing show presence of defects. Right. So testing is conducted to identify defects or errors in software. The goal is not to prove that the software is error-free, but to uncover issues that need to be addressed. Okay. Number 2 is effective testing is impossible, or not effective. Exhaustive testing is impossible. Okay. Exhaustive testing is impossible. So it is impossible to test all possible input combination and scenarios exhaustively due to the resource constraint, time limitations, and the complexity of modern software system. Testing efforts should be focused on areas of high risk and priorities. So the 3rd one is early testing. Testing activity should start early in software development lifecycle. Detecting and fixing defects at early stage is more cost-effective than addressing them later, like we mentioned before. Early testing helps prevent the propagation of defects throughout the development process. So the 4th general testing principles is defect clustering. So in a given system, a small number of modules or functionality typically contain the majority of defects. Focusing testing efforts on this high-risk area can yield a more effective outcome. Okay, so we'll have number 5, pesticide paradox. If the same set, what it means is that if the same set of test cases is repeated over time, the effectiveness of finding new defects diminish. Okay, to combat this, the test cases need to evolve continually, incorporating new scenarios and test conditions. Right? So the 6th one is testing is context dependent. Testing approach and techniques should be adopted based on context of the project, including the requirements, technology, and development methodology. There is no one-size-fits-all solution. And testing practice must be tailored to specific project characteristics. So it depends on the project. You just test based on the project, and they should be context dependent. Okay. So the last one is absence of errors fallacy. So what this means is the absence of dictated defect does not necessarily indicate that the software is error-free. So when you do not dictate, when you during testing and you fail to detect any error, doesn't mean that that particular software is error-free. Okay, testing can only provide information about the presence of defects, not their absence.
Sorry
Yep.
to cut you. Yeah.
Yep.
So there is possibility that you do like defect. Is it defect clustering?
Is it defect clustering?
No, like I just want to know, like, is it possible for you to like search for errors on your software and it's error free completely?
So what it's saying is when you are testing a software, right, and you fail to dictate any error, let's say you are testing a particular functionality and you haven't dictated any error. So it doesn't mean that there's no error on that website. Okay. So because testing dictates the presence of error, okay, and not the absence. So you're not testing to say there's no error here. You are testing to dictate error. So for the fact that you didn't dictate error doesn't mean that that website there's no
error at all.
Yes. Okay. So it just depends on you are testing that particular functionality based on the requirement that you are given.
Okay.
Okay.
Yeah.
So yeah. So because you might be asked to test a login functionality. You have tested that login functionality according to the requirements. Everything is okay according to the requirements. But that doesn't mean that something might not be wrong with that login functionality. If you dictate it, good. But your testing is not to dictate the absence of error, but the presence of error. Okay. Right. So for you to now have tested a particular website and say, yeah, I've tested it, there's no error. Okay. It's a fallacy. That's what it means. Okay. What you can say is the actual condition has met the expected. So you're expecting that so thing and so thing should be working in a particular way, and you've tested it, and that thing is working as it should. Do you get the point now?
Okay.
Yeah. So the next one, okay, which is the fundamental test process. Okay, so we'll go through the fundamental test process. So the fundamental test process, as defined by the International Software Testing Qualification Board, ISTQB. okay, comprise a set of activity and tasks that guide the testing effort throughout the software development lifecycle, right? The process is iterative and adaptable to different development methodology. We'll go through software development methodology. Okay, the key phase of this fundamental test process are as follows. One, test planning and control. Okay, in this phase of test planning and control, the testing team established the overall strategy and approach for testing. Okay, which include test planning. And this test planning involves defining the scope, objective, resources, schedules, and deliverables of the testing efforts. Okay, so then we'll have test control. You know, I mentioned test planning and control. So the test planning involves defining the scope, objective, resources, schedules, and deliverables of the testing efforts. Then the test control involves monitoring and adjusting the testing activity to ensure they align with the project goals. All right. So the second one is test analysis and design. This phase involves analyzing the test basis, which include requirements, specifications, and design documents. So we have the design, we have the requirements in a specification, which could be, in form of user stories and acceptance criteria. We could have design documents, which could be, a Figma design, mockups, wireframes, right? So it could come in form of design documentation. Okay, so you go through all these things, you analyze them to identify test conditions. Okay, test designers that create detailed test cases, okay, test scripts, and test data based on these conditions. So we are the test designers, because you can say testers or test designers, because we design the test cases and the test scripts in terms of automation. So we use that, we can derive our test data based on these conditions. The focus is on designing test cases that cover a range of scenarios and conditions, including both positive and negative cases. So like I was mentioning, if you are testing a login functionality, right? They say when you enter username and valid username and valid password, you should log in. You don't just test valid username, valid password, right? When you have tested valid username, valid password, that is your positive scenario. Okay, you also have to do negative scenarios by using valid username, invalid password. Of course, you'll be expect an error. If you use an invalid username and a valid password and you log in, then that there's an issue on that website, because your expectation is that you shouldn't log in, right? You can also use valid username and invalid password. That's another negative scenario. You can also use invalid. There's another negative scenario. You can use special characters and so on and so forth. That is you doing negative. So your test case, okay, and test script must include valid scenarios and invalid scenarios. So your test data is like your username, your password, anything you're inputting in any input field when testing. Okay, so the next one we'll have is test implementation and execution, right? Testers implement the design test case. Remember, I told you that you plan and then you design, you analyze, and then design your test case. So after the designing, you now implement your design test case. Configure the test environment if you're doing your automation or even manual self. Sometimes you also configure your environment for your manual. Okay, prepare your test data. The actual execution of test case takes place, and the testing team observe and record your results. Very important. Once you are testing, you're also recording your results. You observe the behavior and you take screenshots, or even sometimes you take a video coverage of your results. Okay, that is what will guide your back to say, because sometimes you can test something after testing it and you say, yeah, it's fast, it's working as expected. And when you go back, you realize that that particular functionality has regressed. It's no longer working as. So sometimes they come back to you, oh, did you actually test it? You said yes, it's tested. They will say, oh, it's not working now. You can say, oh, you just forward your screenshot and say, yeah, when I tested it, this was how it was functioning. These are my screenshots. They'll say, okay, maybe it has regressed. But if you don't have evidence to say, I've tested it and it's working, they will believe that you didn't test it properly. Okay, so that's why it's important to observe and take record of your results. Okay, this phase includes both manual and automated testing execution, and it aims to identify defects in the software. Right. So the next one is evaluation of exit criteria and reporting. Okay. So the testing team assess whether the exit criteria defined in the test plan phase are met. Exit criteria typically include a certain level of test coverage, defect resolution, and overall quality. Testers then prepare test summary reports, which provide information about testing activity, test results, or any open issues. Okay, so once you are done executing, okay, now maybe in some contract projects, right? They've given you a project, you are done working with it, you've done executing the testing, you are done with everything. And then what you do is that now you now evaluate, your exit criteria for you to exit, to say that, okay, I'm done. Okay, you now prepare your report as well. Okay, these are all the results, all the tests that was run. This is how many that passed. This was how many bugs that were raised. Developer will work on it, will fix it. If there's anything to raise, you raise them. Okay, so then the last is test coverage activity, test closure activities. Okay, after testing is completed, the test team perform closure activity, include gathering data of metrics, okay, conducting a review of the testing process, achieving test wares, archiving test wares, such as you archive your, test data and so many other things. Okay, test closure ensures that all necessary documentations is completed and the lessons learned are captured for future improvements. It's important to note that these phases are not strictly linear and the process is often iterative. Okay, changes is required. Okay, other project factors, okay, may lead to revisiting early phases. Okay, additionally, the fundamental test processes is adaptable and can be integrated into various software development methodologies, including Agile and Waterfall. We'll come to Agile and Waterfall, okay, later when we'll do software development lifecycle. Right. So from there, we'll now go into different roles in software testing. So it's important that we mention this as well. So the different roles, I'll just go through this quickly. So the different roles is, and this is also good when you are applying for jobs, basically, because you can apply for all these different roles. Okay, you can apply as a quality assurance engineer. Okay, so most jobs have been advertised as a quality. So you cannot say, oh, I'm just a tester. And when you see quality assurance engineer, you want to apply for it. So quality assurance engineer is one of the roles. And then you have test analysts as well. So you can be a test analyst. Some of them are manual testers, which are just for manual testing. Okay, you have QA test analysts. You have UAT tester, which is user acceptance tester, functional tester, agile tester, automation tester. Sometimes you can even have automation test engineer, as the case may be. So these are different roles, okay, of a software tester. Then the next one is software testing skills. So the reason why I'm going through this is sometimes in an interview, they can say, okay, what are the skills that you have as a software tester? So you all need to understand that testers, as a tester, you need to have analytical skills. Okay. Testers need strong analytical skills to understand complex system, okay, identify potential issues and diverse effective testing strategy. Right. So the next one we'll have is attention to detail. Very important as a tester. Okay. As a tester, you must have a keen eye for detail to thoroughly examine software and identify even the smallest defect that could impact user experience. Right. So the next we'll have is problem-solving skills. Right. Testers encounter various challenges during testing, and the ability to analyze problem and devise practical solution is crucial, especially when you're doing automation, even sometimes in manual testing as well. All right. So the next one is communication skills. Okay. So clear and effective communication is vital for testers to convey issue to developers. Right. Whenever you pick up a bug, you create a bug, add all the necessary bug components. Okay. Sometimes the developer will come back and say, no, it's not a bug. Okay. So you have to be able to communicate the reason, okay, and prove it to them that, yeah, it's actually a bug, right? So you need a good communication skill, okay, to be able to collaborate with your team members and document test cases and results effectively, and then be able to convey whatever information you have, right? So the next one that we'll have is technical proficiency. Okay, testers should be familiar with testing tools. You need to become familiar with testing tool, version control system, the kits, Bitbucket, Azure, Repo, depending on which one your organization is using. Because if you let's say you are written automated test, you need to be able to push it to the repository and then create pull requests and so on. If they leave comments on your pull request, you need to be able to go read it, resolve it, and then so on and so forth. So various programming languages, you don't need to know various programming languages. So all you need to know is the one that your organization is using. Most often in an organization, they will ask you to choose what programming language or which programming language you want to use or you're familiar with. Sometimes they could already have theirs, right? And then yeah, so if you know the one that, and know that you don't need to know it up to the level of actually being a developer, all you need to know is know the one that is good enough, okay, to actually write your automated tests. Okay, so some knowledge of automation tool and scripting language is also beneficial. And this sixth one, which is understanding of development processes. So as a tester, you need a good understanding of software development lifecycle. Okay, this will help you to integrate seamless into the development team and contribute to the overall process. Okay, we'll also go through SDLC more detail in our subsequent class. Right, so the next one we'll have is time management. Okay, testers should be able to prioritize tasks effectively, okay, ensuring that testing activity align with project timeline and deadline as well. Because sometimes developers will finish quite late during the sprint and they want you to test, as quickly as possible. So you need to know how to prioritize your task. Know the one that with higher risk, the one that have higher priority, and then focus on those ones. All right, so we have test technique. Testing technique. Of course, a tester should have various knowledge of testing technique, which include manual and automation testing, black box testing, white box testing, regression testing. Okay, this will allow tester to choose the right approach for different scenarios. So if you are quite knowledgeable and you are quite skilled around the testing technique, you know which one to adopt during testing. Okay, we'll come into testing technique in subsequent class. So there are more software testing skills, okay, that I haven't mentioned here, such as collaboration skills. I've mentioned that before, that you need, as a tester, you work closely with developers, project managers, and other stakeholders, okay, the BAs, the Scrum Master, and the rest. You need to know how to collaborate with them to successfully test your software and communicate issue as when due. Okay, you need critical thinking. Testers need to think critically to anticipate potential issue, okay, evaluate risk and assess the impact of defects on the overall system. Okay, then the last but not the least is the customer focus. As a tester, you need to understand, okay, end user perspective and focus on delivering the quality product that meets customers' expectation. Okay, so when you are testing, that's why we adopt the behavior-driven development or behavior-driven way of writing our test case, where you use Gherkin syntax, which focus more on the user. As a user, I want to do this. So when you are writing your test case, you say giving the user navigate to. So you imagine, or you're testing as if you're a user, right? You say giving the user navigate to URL when the user do this, when the user do that, and then will not be the expected results. Okay, so yep. That's it. And then that brings us to the end of our slide. Any question?